Alright, in this video I'm going to show the run animations for the enemy knights you'll encounter in the game. And there's two, so I'll first show them in Maya so you can see them before I implement them in the engine. So I'll just play it. I've slowed it down so that we can see it. So it's just a couple of frames run animation. We'll go from different angles from the back. And I'll also show the one for the skeleton. So even though the skeleton knight and this red knight share the same skeleton rig, we've decided to use different run animations because they just look better on the characters, and also just to have a little bit of variety in the game. So I'll run that one. So this one is a little bit more lively, and this animation will be the one that's running on the skeleton knight. I'll show that later when it's running in the mobile game. So now I'll just turn around so that we can see from different angles. And again, I've slowed it down from what you'll see in the game. So next what I'll show is these animations implemented in the game, and I'll talk about a few of the tests that I've done and some of the optimizations that I've implemented in the game engine to deal with several characters running at the same time. So that I'll show in the next part of the video. Alright, in this part of the video I show the enemy knights, as you can visibly see, as they're running through the world. So these are the animations that I showed earlier in Maya running. And I do this by spawning them in script, so I don't write C++ code to spawn the characters. And how it works is there's a memory pool of these knights, so maybe there's 5 skeleton knights and 5 of the red knights, and I just keep reusing them as I spawn them, so I don't have to do memory allocations. It just keeps reusing the same characters, and once they go off the screen, I return them to the memory pool, and then they just keep getting reused. So that's one of the little tricks. And I use, as always, AngelScript. I'll put a link in the description if you want to look at that scripting engine. And what it also allows me to do with the scripting is I can change the speed of the animation that it's played at, as well as the velocity that the characters move at. So that also gives you a little bit of variety. Some of the characters will move quicker, and at other times they'll move more slowly. The other thing I wanted to test was the load on the CPU when I'm drawing several characters on the screen at the same time. And luckily it worked out fairly well. I had to disable some optimizations because I wanted everything to be on the CPU. And the way this engine's written, if it detects that it can animate the characters on the GPU, then that's what it's going to do. So for instance, on the iPhone, it'll detect that the Metal Render API is available, and in that case I'll animate the characters on the phone. And I could do that also in OpenGL, but I'd have to break apart the mesh and it would increase the draw call. So if your phone only has OpenGL, it'll render on the CPU. So that would be the lower end phones. And that's what I'm testing here. So the first thing I had disabled was animating on the GPU. And the second thing was multi-threading. Most of the modern phones have more than one core. So it's a huge advantage if you can multi-thread a lot of your code and split the work between the number of cores. That way, in theory, you can get your work done faster. I decided to disable that because I wanted to see what the load would be on the CPU without using that optimization. And as you can see, it runs fairly well. I could double the amount of characters that I show. I could even triple it, but then the game becomes unplayable because you just can't dodge that many characters and they're all bunched up. So I tried to go with something normal and also do a couple of, I guess, loads that you'd normally see in the game. And so with this and the other optimizations, I'm in a good place. I'm not in, I guess, a performance bottleneck with the animations. It's chugging along quite nicely. And it doesn't really burden the CPU that much. It's very nominal. And I guess, oh, well, one of the optimizations that I also coded the animation skinner in assembly language. So that way I can use, it's something called the Neon instruction set, which it's sort of like the SIMD instructions that you'll see in the Intel processors. So it allows you to run multiple calculations in one instruction. So it's great for multiplying, you know, using matrix math, that sort of thing. It's special instructions that'll let you skin the character that much more quickly, as opposed to doing it in C++ code. The other thing I do is I do occlusion culling for the characters. That's another optimization. So if the characters are spawned off in the background, like you see over here, if they're occluded by the floor or some of the surrounding geometry, I skip doing the animation because the character's occluded. There's no need to animate the character. So that's another optimization that I do. And that one I decided not to disable because occlusion culling is available even on the lower end phones. So I left that one alone. So I use that one when if the scene's densely occluded, I can skip a ton of these characters. So for example, in this scene, obviously it's not very occluded, but the characters are spawned below the floor. So for the beginning of the run, they're not visible, and that's how I avoid rendering them. And here I'll show how the bump animations work. So each one detects when they get hit. So that'll happen if, you know, you bump the character and your game ends, or if you want, you can replay if you've got extra lives. So that's pretty much a quick summary of what I've done with the animation engine. I did a test of what you'd normally encounter in the game, and thankfully I encountered that on performance-wise I'm in a good place, so I can increase the number of characters past what would be playable in the game, and it'll be okay. And even if I enable all the optimizations that I have, I'll be able to draw even more characters. But of course, that makes the game unplayable, so I probably won't do that. But hopefully this will help anyone who's working on their own animation system to consider some optimizations. And for now, that's what I have to show. Thanks, and bye.